Thanks very much, everybody. I am Pat. I run the engineering team at Ryft. We are a company based in Rockville, Maryland. My first FPGA was a Xilinx 3090 back in the early 1990s. My second was a 4008, and I thought that was the cat's meow. And now I'm running on a VU9P in the cloud. It's pretty cool. So we got our bones in the DC area, so you can imagine what that means. It's government contacts, government relationships, very large, true big data problems. Big data to us is measured in petabytes and exabytes already, not gigabytes or even low terabytes. And that's a challenge, especially in the cloud, for a lot of different use cases. But the government is all in on the cloud. We'll talk a little bit more about that and how we're changing things up both commercially as well. So who is Ryft? What do we actually do? We do data analytics. We also do certain types of signal processing and signal intelligence, as you might imagine, but our bread and butter is data analytics. And what that means from our standpoint is understanding first and foremost, not the low-level hardware engineers that make our company what it is today, not the electrical engineering or the computer science or the math, but turning that on its head and coming top down. And that's the challenge for the FPGA community today in our eyes. And that's why we were ecstatic to see Amazon embrace heterogeneous computing, what many of us have been talking about for a decade or more now. And no offense to GPUs, but GPUs don't count. They just don't in this space, so to speak. You can't just have them by themselves. They need a CPU, similar to the way FPGAs need a CPU. Xilinx already understands that with the Zinc, right? So this is not news to anyone in this room. What is news potentially to some of you is the importance of going top down. That's critical. The end users, and both Ramin and Gadi mentioned this, the end users these days are not FPGA experts. They can't even spell FPGA, and that's okay, right? That's okay. Embrace it. It's okay. If you work at Xilinx, your goal should be, I want to be under the covers making millions of dollars, and I don't want anybody to know my stuff is there. I just want them to know it's better, stronger, faster, and I'm getting paid for it. And that's the way we look at this too. So where do we live? We live in the middle of this slide, between those two blue lines. We build those fancy icons that I did not draw because I can't draw. Those are the individual algorithms that run on our hardware and now also in the Amazon cloud. Each one of those is partially reconfigurable. And some of you, I actually recognize people walking out there. We did a Club Vivado demonstration on partial reconfiguration late last year, me and my FPGA team. And it was very well received. And Amazon has taken that one step further. And soon, Xilinx will be taking that one step further more. And that would allow us to do things like partial reconfiguration inside of partial reconfiguration, which is going to be critical in the cloud. These kinds of workloads really change the game in heterogeneous computing because it means that you're not just limited to one thing, but you can then load all these things whenever you need to dynamically over time. And that is the one main advantage Xilinx still has over every other FPGA competitor in the world today. That's why I chose them, both for my hardware, and that's why we're very pleased when Amazon chose them for the cloud. It made us a seamless operation to get over there. The platform is just a platform. Our stuff will run on our own hardware, it'll run on the cloud, it doesn't matter. And that is absolutely critical. We found that in order to make the right architecture, we had 20, 30, 40 man-years of effort we had put into our own appliances. And Amazon and us started talking, and we had to figure out how in under a year to get all that stuff ported over to the F1. And we did it. What you see here is that architecture. So this is the actual architecture that we have in the F1. And all these slides will be available to you guys, so no worries about that. You'll notice there's no proprietary markings at all here. There's a white paper we did in conjunction with Xilinx. That white paper goes into gory technical detail. It's not marketing fluff. You'll actually see timing analysis in there and why we did what we did and the architecture. Go ahead, pull it down, read it. It'll really help you, I think, when you're trying to port your own hardware applications to the cloud. The blue is what we did. The orange is Amazon stuff. Now, it's not exactly accurate because we're not directly interfacing with the DDR. We're going through Amazon shell to do that. But you get an idea of what's going on here. This is not rocket science to any of you that have solved data problems in FPGAs. It's straightforward. All those blue rectangles are the plumbing, just moving the data around to that far right blue cloud that you see. Those are the collection of our partial reconfiguration primitives that you saw on the previous slide. It's things like exact search and fuzzy searching, which can feed things like machine learning. It's doing term frequency analysis for index generation. It's doing IPv4 and IPv6 analysis for cyberlog things, all at the same time, all mix and match, all on the same or different instances, or on same or different pieces of hardware. And that beautiful model actually gets to what Ramin said earlier about you've got some edge problems and you've got cloud problems, or data center problems, I should say. And those two things together are really what's going to shape the future of data explosion that we're seeing, especially with, I hate buzzwords, but the Internet of Things, it's happening. And it's starting with, as kind of Ramin mentioned, some of the automated driving stuff. So what did we do with F1? Well, we announced last week a whole slew of marketplace offerings on AWS F1 and also on other Amazon instances too. We try not to be FPGA bigots or CPU bigots or even GPU bigots. We believe that the way you solve a customer problem coming top down is use the right tool at the right time for the right job. And that means that you've got to have the right CPU resources in play, you've got to have the right FPGA resources in play. And for certain applications, maybe the right GPU stuff in play. So on the left side here, you see our toolkit offering. Our toolkit is the APIs that allow a developer to directly access this stuff. It's things like programmatic interfaces for C and C++ and Python and Ruby and Bash and command lines, and it's all built in, it comes natively with the stuff. And that allows the software development environment to directly bolt up to our acceleration if they need to. On the right side is our first top-down application offering, and we chose, given our government backgrounds and the customers there, to focus on Elasticsearch. If you're not familiar with it, Elasticsearch is an open source framework that allows you to mine data. They would say relatively fast, I would say slow as a snail, because they have to index that data first. It's like any typical database. Think about the old school textbooks from classes 20 years ago, right? I don't know what they're doing today, but I remember I had to go in the back and look at the index and find something, and if it wasn't done very well, I couldn't find it. Well, that's what these tools need today. All these database tools have to index all this data, and that can take days, weeks in some cases. And when you start getting into petabytes, it's outrageous, because you have to load this data, get it in the right format before all these software tools can analyze it. So what we did is we used the power of Xilinx FPGAs, both on our own appliances and in the cloud, to solve that problem. And we now can do all of that data analysis without having to do any special loading. So if your data is in JSON, or JSON if you prefer calling it that, I don't give data a person's name, then blammo, analyzes it directly as is. If it's an XML, directly as is. Comma separated value, directly as is. Some unstructured format you don't know about, directly as is. This slide here gives you kind of a feel for the acceleration piece, but that's only one piece, and I'll tell you what I mean by that in a second. 90x, 91 if you go to the strict numbers, is how much faster we are on F1, which only has, this is an F1 2x large, mind you, so only 8 CPUs and 1 VU9P, compared to a C4 8x large. 91 times faster. Now, I checked the pricing last night on these two things, on the hardware pieces of this. The hardware pricing last night for a C4 8x large was $1.59 an hour. The pricing for an F1 2x large was $1.64 an hour. Now, as an end user, your customers, do you want them to spin up 91 C4 8x larges, or do you want them to spin up one F1? That's a tremendous advantage that you can have just by using FPGAs for the right thing, but not going overboard and knowing when to leverage the CPU architecture or a hybrid edge cloud architecture. And that's really what I mean by top-down, as I mentioned earlier, is understanding your customers well enough to know what can I accelerate in a way that they will care. But it's not just about acceleration. It's about remembering that they have to be easy to use. They can't have to do anything special. You can't teach an old dog new tricks. You just can't. They like their tools. They like their Elasticsearches. They like their SAP HANAs. They like their Google Earths. They like their Tableau visualization. They like the genomics tools. Let them use them. Just write the APIs to make it easier for them to get the acceleration for free. But I said there's something besides acceleration. And that is, FPGAs give you something that CPUs and GPUs cannot give you. They give you the ability to invent new solutions, new architectures. You're not limited to von Neumann anymore. You can move the data around in between these partially reconfigurable regions whenever you want to do whatever you want it to do. And the beauty of that is you get new features. So a person using Elasticsearch today, if they want to do a fuzzy search, they effectively can't. There's a thing in fuzzy searching called distance, and it means how close is this thing I'm looking for to what I actually found. It's very limiting because of the way they do indexing. With FPGAs, that problem goes away because you don't have to index the data. You can push the data through these very wide pipelines very fast. Things that CPUs and GPUs simply cannot do because they're constrained by bus widths. You define your own bus widths. You define your timing. It's beautiful. Last but not least, this last slide I'll show you here is kind of like I won't lie to you, it was not exactly easy for a hardware-based company to embrace the cloud. Our biggest problems were not technical. We solved those pretty simply, and Amazon was a phenomenal partner to get this done and work through the hiccups that you always have doing hardware development. And make no mistake about it, F1 was hardware development to get it off the ground. The biggest challenges were the cultural challenges. How do you leverage your culture and your people? And as any good manager or good kind of business person knows, you're only as good as your people. So you have to be able to change that culture, that mentality of, hey, look, we can't look at this as a bottom-up, hardware-driven world anymore. It's top-down, software ecosystem down. And that was hard. And in Marketplace, it was hard because we had to convince ourselves that, okay, who of our current customers care? And at first we were like, nobody cares. And then we found out quickly, oh man, were we wrong? Everybody cares. Even the government cares. There are now government-facing clouds that are going to get this stuff in the coming months. And we got to be ready for that. Our customers are going there. So are yours. And so we're leading that way now. Our sales force is now cloud first, appliance second. Why? Well, first of all, it's hard to build out a massive sales force and go knock on doors. Here, I can search for Ryft on the Amazon Marketplace or search for Elasticsearch. And up comes Ryft's low-cost acceleration option that gives you 9 times better performance at 9 times less cost. Who's not going to try that? If you go and do this yourselves, and I hope that you do, because if nothing else, for you developers that are out there, which is the majority of you, this is the world's greatest development board platform now, if you really think about it, right? You can spin up a VU9P in a minute, and it's at your disposal. Use the private listing service first if you're going to spin up in Marketplace. You'll iron out your hiccups. You'll work with the right people at Amazon on the business side to get all that working. For a company like us that was hardware focused, that was kind of hard at first. But once we got the hang of it, and Amazon was very helpful there, it was easy as pie. And with that, I'm going to pass it back over to Gotti, and he's going to pick up right where he left off.